When you're working with radical expressions within a problem, you want to use them in the simplest form possible. In a previous video, we already talked about one form of simplifying them, which is that each radical should contain the lowest possible whole number. For example, radical 20 would be written as 2 radical 5. There are a couple of other rules that we're going to look at in this video. One is that an expression should contain as few individual radicals as possible. Here's an expression that can be simplified by using the distributive principle. If we distribute the radical 3 over this parenthesis, we'll get 5 times radical 3 plus radical 36. Radical 36, you know, is 6, so your final version is 5 root 3 plus 6. Here's a bigger multiplication problem. In this case, we're multiplying a binomial times a binomial, so we could use a multiplication box. Or we could just write out the 4 pieces. Let's do that. The first piece we need is the 3 times the 2. So that gives us 6. The next piece we'll need is the 3 times the negative root 5. That gives us negative 3 root 5. Then we need the positive root 5 times the 2. And lastly, we need the root 5 times negative root 5, which, as we know, gives us negative 5. Now we just have to collect like terms. The 6 plus the negative 5 gives 1, and the minus 3 root 5 plus 2 root 5 gives minus root 5. So we've come out with a much simpler answer than we started with. There is one more rule for simplifying radical expressions, and that is there should not be any radicals in the denominators of fractions. If we run across some fractions, let's see how we would simplify those. Here's a fairly simple one to start with. We want to get the square root of 2 out of the denominator. Now you know that if you multiply the numerator and denominator of a fraction by the same number, you haven't changed the value. So let's multiply this one by the square root of 2 over the square root of 2. That will give us a whole number on the bottom, which is what we're trying to achieve. So 3 radical 2 over 2 is considered to be the simplified version. Let's look at a slightly fancier one. 4 plus the square root of 7 over the square root of 7. What we need to multiply by in this case is root 7 over root 7. And this will give us 4 root 7 plus 7 on the top and 7 on the bottom. So once again, this is considered a simpler version of the fraction. Here's a problem that's a little trickier because the denominator has a radical in it, but it also has a whole number. So we're going to have to think a bit about what to multiply by on the top and the bottom in order to get a whole denominator. To do this, we'll use the idea of a conjugate. The conjugate of an expression like we have has the same shape and the same numbers, but the opposite sign. So, for example, the conjugate of 5 minus root 8 is 5 plus root 8. Let's multiply those together and see what we get. Once again, we'll just write out the 4 pieces. So we get 25 plus 5 root 8 minus 5 root 8 plus minus 8. Now notice that these 2 pieces, when added together, add up to 0. So the simpler way to say what we have is just 25 minus 8, or 17. This might seem familiar to you if you think about the difference of two squares, which is a pattern you've seen in algebra. When you multiply x plus y times x minus y, you get x squared minus y squared. So we're going to use this idea to simplify our fraction. So the thing we want to multiply by is the conjugate of the denominator over itself. Let's go off to the side and see what the denominator is going to turn out to be. 3 minus root 2 times 3 plus root 2 will give us 9 minus 2. Once again, the middle terms will have fallen away, which makes 7. So our new denominator is going to be 7. So our final answer is 18 plus 6 root 2 all over 7.